Today we're going to get into the tangent function, deal with that a bit. This is the second page of the packet you picked up on the way in. So we're going to actually start there today. The front page is your warm-up, but since we have a shortened period, we're going to skip that part, and you can do it as a review later if you'd like. So on this, make sure as you're trying to deal with number of cycles and period for tangent, I will tell you it's different than sine and cosine. Make sure that you're in the correct viewing window here. So set your window here, and then enter these as your y sub 1, y sub 2, 3, and so on. And then go ahead and fill out that table, please. Okay? So putting that into our graphing calculator. Make sure you're in which mode? Radians. Hey, everyone should have them in your graphing calculator, making sure that you recognize this is 0 to 2 pi. So if we're graphing it on our x scale, we're starting at 0, we're going out to 2 pi. We're going up by pi over 8 every time. So that's our interval. -4 is our low mark on the y-axis, and +4 is the high mark on the y-axis, and that scale is going up by 1. Alright, so if I'm dealing with this, we're still in the form of y equals a tan b theta. And so when I'm looking at these different things, we would actually say, well, a in this one is 1, b is 1. Okay. The number of cycles, however, when we actually graph that, that's 1 cycle, and there's our second cycle. Notice you see 2 iterations. If you put these 2 pieces together, that's 2 iterations there. Therefore, there are 2 cycles here. And the period length is actually, there's half a cycle, here's the other half. So if we just kind of look at that part of the graph, that is a period length of half of 2 pi, or pi. Okay? We're to graph the next one. Okay, now we're at a is still 1, but b is 2. Okay, how many cycles are there? Good, 4 cycles. And so if there are 4 cycles from 0 to 2 pi divided by 4 is pi over 2. Yeah. Each one is pi over 2. So when you start thinking that you're seeing a pattern, then start making predictions on what it's going to be here. The number of cycles in this one is 1, 2, 3, 4, 5, 6, 7, and then the 2 ends are 8.
Wait, so is the number of cycles always twice the number of b, or is that just a coincidence?
Well, that's what you should be looking at, trying to find those patterns. What's the period? Pi over 4. Is anyone starting to see the patterns? I know Walsh saw one of them. It appears as though the number of cycles is, number of cycles is always 2b. Just multiplying b by 2 every time. Anyone figure out the pattern with the period yet? Yeah? Yeah? Yeah, it's pi over b. Okay. Taking pi, dividing it by b. Okay. Pi divided by 1, pi divided by 2, pi divided by 4. So notice we kind of stopped changing b, at least until the bottom here. Let's go down to the last graph. Let's make predictions here. So a is 3, b is 1/2. Therefore, the number of cycles is going to be, you should only see 1 if these are true, and The period is 2 pi. Pi divided by 1/2, or 2 pi. Oops, there it is. Okay, we see one iteration, and that has a length of 2 pi. So what does A do? Matt? The curve of the line? So if I graph, say, this guy here, and then drop down here where A is changed to 2. Oops, I left the other one still graphed there. All right. By the way, those of you that would like, how many of you graphed them all at once at the very beginning? And you had to wait for them all to graph? If you want to interrupt that, if you just hit second on, it'll interrupt that graphing. Just for future reference. Second on. Okay, so here is the parent function. And then here is the parent function multiplied by 2. Okay, so that is doing a vertical stretch. A is doing a vertical stretch of it. Okay? Zach, let's focus up here. Okay? I know you're probably watching some amazing YouTube video on graphing. Oh, nice. So you were watching a graphing calculator. Okay, all that stuff was down on the bottom. If you want to check your work, it's all down there. Yeah, it's all right there. You believe that? What a tricky thing. All right.
More like what a triggy thing.
Tricky thing. Yeah. Good job. Okay. Hey, any questions there? All right, let's go ahead and turn the page, please. So we're going to continue graphing the tangent function. Some of you look really pumped up about it. Okay.
Yeah.
Just to remind you, the period is pi over b. Number of cycles is always 2b. The little pattern that we use to help remember how to graph these, rather like last week, is 0 max, 0 min 0 for for sine, and then max 0 min 0 max for cosine. For tangent, it's 0a asymptote negative a 0.
Well, that's a fun one to say.
Yeah, that one's a little harder to say. Okay, but I mean, really, that is what the kind of the process you're going through. So, using that, let's make sure we get the parent function graphed, and then we can go through why everything is what it is. Okay, so if I'm just graphing from 0 to 2 pi here, I would have A is 1, B is 1. So the number of cycles is 2b, or 2, and the period is pi over 1, or just pi. Okay? Thank you. All right? And so we'll go 0, A, which is 1, asymptote, negative a, and 0. That is one cycle. So from here, please make sure that it's curving outward, not inward. Okay? It'll almost feel like you're drawing half of a parabola, kind of. All right? That length is pi. When you're graphing tangent functions, I expect you to label your zeros and your asymptotes, which means this is pi over 2. And then if we continue it to get our 2 cycles in, to get out to 2 pi, we'd then have A, asymptote, negative A, oops, wrong spot, negative a, 0. Okay, so we have that full branch in the middle, and then our half branches on the outside here. So this will be our 2 pi. This will be 3 pi over 2. All right. Now, what makes this graph different, there's some asymptotes there. Remember tangent? Tangent means what over what? Opposite over adjacent, or in the unit circle, thinking sine theta over cos theta. Now, when we're dealing in math, an asymptote graphically is when you have an undefined value in your fraction. At what point is cosine undefined on the unit circle? Or at what point is it 0? Math? 90 degrees. Okay. Yeah, 90 degrees or 270, or 90, which is pi over 2, and 270, which is 3 pi over 2. That is why we have asymptotes there, because at that point cosine is 0, and we're dividing by 0. So think about the other functions we're going to be graphing. We're going to be graphing secant, cosecant, and cotangent. All of those are reciprocal functions, meaning they all have potential to have a 0 on the bottom, which means they will all have an undefined, an asymptote.
Whoa!
Okay?
Hurry up, guys.
So they'll all have asymptotes. All right. Hey, make a note to yourself why you actually have the asymptotes there. There's a reason for it. Okay? It's when cosine is 0 on these. Okay, that is your parent function. Any questions? Why don't you guys try the next one there? Hey, everyone's attention back up here. A is negative 3. B is 1. Number of cycles is 2b, which is 2 times 1. And P is pi over b, which is pi. Okay, now, really the negative does what? Good, it reflects it over the x-axis. Okay, so remember that's a reflection over the x-axis. So all that means as we're graphing these, if you're thinking of this, this would actually be 0, negative a asymptote, positive a. Okay, so as I'm looking at it, what was up here will now be down here. The asymptote, when you flip it, doesn't do anything. And neither do your zeros. Okay? But a is 3. Good thinking. So we're stretching it by a horizontal stretch of 3. So rather than being 1 unit away, we're 3 units away. Okay? So we have that. We have that. And then, really, the graph is very similar to the parent function with the exception of the reflection and the stretch. So, as you're graphing it, kind of the pattern you go through and the number of cycles you see are the same there. Please take time to actually make the curves look accurate on these. This is 2 pi, 3 pi over 2, pi, and pi over 2. So very similar in terms of your zeros and asymptotes. Vertical stretch. Did I say it different? Oh, yes, this is a vertical stretch. If I just said horizontal, it's vertical. My bad. Good catch there.
I'm just hoping that the final is just like.
Yeah, you'll just like it. All right. Okay. Next one. Example 4. Give it a go. Negative 3 tan 2 theta.
How many examples? Oh. They're all example 4.
Yep, they are.
I thought it'd be like.
Just to mess you up. Okay, how many got the correct piece up here? A, B, number of cycles, and period. Remember, number of cycles 2b, so 2 times 2. Quiet, please. Period is pi over b, or pi over 2. Okay, so we're starting here. This is a reflection because of that negative. Okay, so rather than going A, we go negative A, and then positive A here. Start here, go down to 3. So it's, once again, very similar to our previous graph, with the exception of our scale is going to change, and we're going to see more cycles. Unbelievable. I am having a rough go drawing my curve here. I don't remember that time.
Oh! McCoy, you heard me. I was like, you remember that time we did joke? Me neither. I don't remember that time. Ow.
Trying to remember. All right. So, this would be 2 pi. Half of that is pi. Half of that, pi over 4, or pi over 2. And then half of that is pi over 4. So our first cycle ends right here at pi over 2, which is what it says it should. That's a good check there. So 1 pi over 4, 2 pi over 4, this is 3 pi over 4. 4 pi over 4, 5 pi over 4. 6 pi over 4, which is 3 pi over 2. And 7 pi over 4. Then 8 pi over 4, 2 pi. Questions on that guy? Okay, let's go ahead and fill out this next piece here. We're going to do it together. So A in this one is 5. B, this theta can be written out here. It's pi over 2. So the number of cycles is 2b, or...
Not to be.
Ha ha ha.
Oh my gosh, I put that on this poster.
Okay, yeah. Nice, good job. Okay, pi, that was a good one. I do remember your pi. Okay, pi, and p is pi over b, which is pi over 2, which is... How many pi over 2's fit into pi? 2. Thank you. It's 2. So the period, hey guys, remember, if you see pi in the equation, then when you have your scale, you will not see pi in the scale. Okay, so your period length here is 2. As you go through and do this whole setup, 0, max, or excuse me, 0a, asymptote, negative a, 0. Okay, you're going to see that 3.14 times. Well, there's one of our 3.14. If I could actually draw that curve going down, I keep messing that up. Okay.
How does McCoy not have a
What? Thank you for bringing up a sore subject there.
I just feel like you hold a pencil so often.
Some of you got the joke.
Wait, what did you say?
Bring up a sore subject. Get it? Sore.
Oh yes, there's 3. Hey, you could just go up. If from here, that would be 0.25-ish. Okay, a period length, that's the length of 1. So this branch with this branch right there, that's the length of 1 cycle. So that's 2, right? The period is 2. So the length of 1 cycle from here to here is 2. which means half of that is 1. So 1, 2, 3, 4, 5, and that is 6. This is 6.5 actually. We only needed to go to 6.28, but we went a little further just because we needed extra credit.
I can't wait to do a portfolio page on this.
Woohoo! Rory!
I actually kind of excited, so I actually like this.
The number of cycles is pi. That means 3.14 cycles, and there's always twice as many cycles. Right? So we not always twice as many cycles. We need to go from 0 to 2 pi. That's what I asked us to graph. 6.28 is 2 pi. Okay?
It's 2 just saying each cycle is worth 2.
Each cycle has a length of 2. Yes. Okay.
Oh, I need to do pi cycles.
I graphed one too many.
Okay. Yeah.
Ladies and gentlemen, take a look at page 266 of your student journal, please.
Extra credit.
Hey, pay close attention here. Your homework. Hey, listen. Your homework. Number 1 and number 3. Okay? Those you must do a complete graph of. Complete. Hey, on numbers 2, 4, 5, and all the other graphs here. On all the others, you need to follow out the pattern. So for instance, if we're doing cotangent, I want you to put points where the tangent graph would be for the same A and B values. Okay? If you're doing cosecant, I want you to do points where the sine graph would be for the same. No, I don't want you to graph cosecant, just graph sine 2 pi. For secant, graph 2 cosine 2x. For cotangent, graph 2 tan 1/2 x. Okay, if you do not graph these tonight, pay attention. If you do not graph these tonight, then tomorrow when we start this lesson, you will be mega behind. Okay?
So, yeah,